Hello, in this video we're going to look at some more compound interest examples, but these examples are calculating an interest rate or a compounding amount. So this first example, Henry has borrowed $400 for 2 years and it's matured to $520, but we don't know the interest rate. Now, it's saying compounded monthly, so the very first thing I'm going to do is take this 2 years and calculate n, which will be 2 times 12, which is 24. From there, I can calculate my I using the formula. So I is equal to the future value divided by the present value to the power of 1 over I minus 1. Put this in your calculator, you'll get 0.010991815. Now, this is a decimal, we need to turn it into a percent, and this is technically the periodic rate, which is the rate per month. We need to know the rate, the nominal rate. Okay, so we're going to times it by 12 because of the monthly thing, and we're going to times it by 100%. So we get an interest rate of 13.19% interest compounded monthly for our final answer. Again, when you're doing these, be very careful. This, as I said, was the periodic interest rate. We want the nominal interest rate. Example 2. Monica's invested $1,200 and it matures to $1,500. She's invested for 1.5 years. Her money's been invested semi-annually, so we need to take the 1.5 times it by 2 to get 3. And again, semi-annually is twice a year. Now we can calculate I, which will be the future value, over the present value to the power of 1 over 3, 1 over n, minus 1. And we get I equals 0.077217345. And this time, that is the semi-annual rate, so we times by 2 to get the nominal rate. So our answer is 15.44% interest compounded semi-annually. And that'll be your final answer. Now let's do a couple examples where we figure out n, or the number of compoundings. Now here we have Beth investing $4,400 and it matures to $6,000. We have 7.8% interest. We're going to have to take that and divide by 52 because this time it's weekly. So your interest rate will be 0.0015. Now I chose 7.8 because it works out nicely. If it doesn't round nicely, keep lots of decimal places. Now from here, we can calculate using our formula. So n equals ln of future value over present value over ln of 1 plus I. Now before we go any further, ln, okay? This here is what we call ln, the natural logarithm. Now, we use that to solve exponential equations. In D2L, I did post a lesson on logarithms and natural log and what they are, how to convert to them. But in reality, for this course, all you need to know is how to calculate. So make sure you can use your calculator. There's a ln button on your calculator. All right, so from here, put it into your calculator. Make sure you use the proper buttons. Make sure you use the right view features, or do it in multiple steps, and you will get an n of 206.925. Now, for n, we will always round up the nearest whole number. So we're going to round this to 207. This will be 207 weeks. Again, always round up. Okay. Now, 207 weeks I would accept, or looks nicer is 3 years and 51 weeks. Here's another example of finding compoundings. So we have 5.5%. We're going to take that and divide by 12 because it's monthly. This gives us 0.004583 repeated. Keep extra decimal places. Then we can calculate n using our same formula. So ln of the 2680 over 2000 divided by ln of 1 plus our I put this in your calculator and we will get 64.0014. So this would be 64 months, or 5 years and 4 months. Now, I did say we always round up, so I would also accept 65 months for this one. The reason I just went to 64 is because it is so close to 64, but in reality, often you will round up to 65. This is one of the ones where I would accept both. If you're ever in doubt, just round up.